All right. Well, good morning and happy Friday. It's September 27th. And in less than a month, we will be meeting in person on Friday, October 25th. Those of you who were interested in doing some dissections, that'll be at 11:40 a.m. in the Vet Tech building on the Elkhorn campus. And it's going to be in room V106. Again, you can bring I don't know what the weather's going to be like. It could be wet and rainy and cold. It could be bright and sunny and warm. It could be somewhere in between. So, dress appropriately. The way the building is set up, we can, if you have coats and bags and potential hazards, we can manage those for sure. And again, if you want to bring a laptop or a tablet or anything like that, certainly your phone, any tool of technology, a notebook, a small notebook, or a large notebook, whatever you want to bring. You don't need to bring a textbook. But anyhow, those are all items that you can certainly bring if you'd like. And again, I'll remind you every Friday between now and then. So, the other thing I wanted to mention, and all of you are here and you know this, but the Zoom link for each week is the same. So there's no change in that. A couple of other items. Let's see if you haven't finished. I think all of you have done the lab safety, so we're good there. And I think most of you have done the McGraw-Hill Connect. Gotten set up with that. A couple of you are still working on getting that done. And again, you have plenty of time. There's only one due date for this entire course, and I know in your My Gateway, I think it has the last date of the course being the day after Thanksgiving, Black Friday, which is I think November 29th this year. That's not the case. We go an extra week. So I don't think we're going to meet in Zoom necessarily on Friday, December 6th, but that's technically the day you want to try and have everything in by. Now, if you need the weekend, and that basically means, so what do you need to do? Um, there's no midterm and there's no final. I think a few of you have asked about that. There's no midterm, there's no final. What you have are a series of unit quizzes, and then you have module exams. So you'll have five. And again, all of this actually is going to be in your syllabus as well. So I'm going to go there. Again, these are just reminders. I know a lot of times week one, we look at the syllabus and then we kind of set it aside, never look at it again, and then ask questions that are the answers are in the syllabus. So anyway, it's not a big deal. I certainly enjoy hearing from all of you, and it's good to touch base. But again, if you're ever uncertain about things, just check the syllabus, and sure enough, you're going to have there are 14 unit quizzes and then five module exams. No midterm, no final. You're going to have a handful of these Connect assignments and labs. The lab quiz you've already completed. At the very end of the semester, you'll do a reflection, and then you'll also be working on your State of the Planet project toward the end of the semester as well. So that's how you're going to be graded overall. So at this point, you should have completed the lab quiz. And I would say at least we did the first lab, and then we did osmosis and diffusion, and then there's a thyroid regulating endocrine one. So you should have at least, I would say, three, if not four labs completed. We're going to do the muscle stimulation one today. So that's where I would say you want to be with the labs, having at least one done, but hopefully you're done with three or four of those. And then unit quizzes. At this point, unit one quiz you should have completed, and most of you have. And again, you have uh, unlimited time. It may have a timer, but you can go over it without penalty. And you have unlimited attempts, and it's supposed to record your highest score. So if you do take it more than once, and the score that's recorded is not the higher of the two is not the one that's recorded in the grade book, you need to let me know and I'll take care of that. But I think the settings are correct. Let's see. Same with any of the McGraw-Hill Connects. If you notice that you've completed some of those labs in McGraw-Hill, but the scores are not uh, transitioning over to not my gateway, Brightspace. I actually want to say Blackboard, my gateway, blah, blah, all these different things. But anyway, to Brightspace, if you notice in Brightspace that your grades for the labs are not moving over from McGraw-Hill, you need to let me know as well so we can get that connected. Let's see. So, and as far as the quizzes, again, quiz one, you should have completed that, hopefully. I notice most of you have completed it, and most of you did really well on that. Again, you can take it unlimited times, so please take advantage of that if the score that you attained wasn't quite what you were looking for. And again, you can use your books, you can use your notes, you can use Google, you can use Chat GPT, use whatever you want. I don't know if I trust certain things, but I definitely trust the textbook. So speaking of which, I want to come up here as a little side track. There's the textbook. The college bookstore has this, a physical copy. You can also attain an e-version of it. From the publisher, but there's the ISBN. If you're looking to purchase it online, you could copy and paste the ISBN number, put that in the Google machine, and go to, eBay or Amazon, and you might be able to find it that way. But again, the college bookstore has that, and then you also need to attain the McGraw-Hill lab. So again, I know some of this sounds repetitive, redundant, and old news. But I've been receiving emails from a handful of you this week, so I want to just reiterate what's going on. You do need the textbook and you need the McGraw-Hill, and you work at your own pace. But my recommendation on the checkoffs is that you try to stay generally on track with the course calendar that is also found right here. Okay, so we are actually kind of ending this week here. We started on a Friday, so we actually started on the 12th, so or the third Friday. I don't know when we started. We started on it was after Labor Day, so maybe it was the 6th. I don't know. But anyway, we're basically wrapping up musculoskeletal. So that's really where you need to be, is finishing up module one and the first three quizzes. So I want to discuss a little bit with musculoskeletal today. And then next week, when we get together, we're going to dive into the nervous system. Yeah. And then this is the date, the 25th, where we're going to be together. This is a good timing because we're ending cardiovascular, starting respiratory, getting into digestive a little bit. So everything that we dissect is going to be nervous, special senses, some blood, cardiovascular, and then we're going to look at these two systems on the 25th as well. So anyway, there's the course calendar. Again, these are not necessarily due dates. They're simply milestones that you want to be at or checkpoints that you may want to consider being at. All right, so you should be coming up on your first module exam. And yeah, the questions are from the pool. So anyway, let's get back to it. And again, if you do have questions about any of that, please email me. I know Brightspace is new and navigating it may be a little bit new for some of you. I don't know, some of you may be used to Blackboard or a different type of learning management system. But so anyway, it may take a little bit of getting used to. But again, we're in module one, and you always have the outlines. Yeah. Now, for this week, bones, muscles, I have the slides here. Oops. So we're going to look at those. One thing I don't necessarily care for about Brightspace is that it opens in the window and then you have to go back. And anyway, it's kind of clunky sometimes, but anyhow, that's the way it is. So I did put a couple links to some short videos. Um, if you watch the integumentary video from last week, which I hope you did, that you the skeletal system video and muscle system video will be familiar if you watch the integumentary. It's the same person who does an excellent job of explaining some of the basics in a very straightforward way, and she's a veterinarian as well. So let's see, and then of course there's your quiz. No, there was. Okay. So your slides for unit 3, and then your um here they see this, see what I mean? Sometimes trying to find stuff. And then you have your outlines, unit 3 outlines. This I believe would be the um uh yeah, the Google Doc. So you can get the Google Doc of both uh, chapter 7 and chapter 8, the skeletal and muscle system. And again, these go right with your textbook as well. So as you're going through your textbook, you may want to highlight or make notes. And again, these are view only, but you can get access these documents and make copies of them, or you can download them as Word docs. So then they're yours and you can edit them any way you want. So that's my recommendation really, is that you type right into or take notes by hand, however you want to do it. But you can certainly use these outlines as a way of taking your own notes. But again, the copies you have in front of you are read only. So you could print them off too. But anyway, you can also make copies, or you can download. So you can make a copy, it'll be in Google Docs, or you can download a Word doc. So either way, you can access this to where you're able to edit it any way you'd like. So anyhow, this goes through and follows along with my PowerPoint slides, or I guess they're Google slides technically. Okay. And again, you know, you're learning a lot of information in a short period of time. The idea isn't necessarily that you feel like you have to know all of this information in a short period of time. You need to know the basics. You need to be exposed a little bit to some of the terminology. And as you go along, you're going to be collectively kind of putting this entire puzzle together. So, and again, we don't expect you to have all of this locked in for the future in a week or even in a month or even in 3 or 4 months. So, but what we do expect is that next semester, when you start taking more vet tech classes, and the semester after that, when you continue taking your vet tech classes, that the information isn't completely new, that you recognize the terms, you recognize the regions and the areas and generally kind of the locations of where these items are. So generally speaking, it's a lot of information. It takes a lot of time, and you're going to be in the program for, I don't know, probably close to 2 years. You're in the very beginnings of it. So again, you really try not to get overwhelmed with all of the details, but at the same time, try to at the very least look over all of the details. So anyway, how you approach the learning, how you approach the understanding is really up to you. And a lot of you are maybe new to Gateway, and you want to remember that we have the Learning Center on all of the campuses. So please take advantage of those if you're having issues with prioritizing or time management or study skills or just general organization. So, but when it comes to the actual material, it's all right here. It's all in your book. It certainly is in the videos and on YouTube and in other places on the internet. So accessing the information is is a cinch. So I think really today and tomorrow and in the future, once you're working in the clinical setting, we really want you to be able to collaborate and to problem solve and to think critically in the job. But we also want you to understand that the information that you need is always at your fingertips. Um, so anyway, that's my quick little uh, side note about kind of how to approach all of these details because it is a lot of information and there are a lot of details. I've been studying the anatomy and physiology for longer than most of you have been alive. So, and I still, there's still things I don't know. So I'm still learning along the way. But so it is a lifelong process. So anyway, look through these, watch the videos that I have linked, and take some notes. And then again, here's the muscular system one as well. Now, there are, you know, 200 plus bones, depending on the animal. We're symmetrical, so a lot of times these bones come in pairs, so that makes it nice. The other thing is, the vertebral column, the ribs, the toes and the fingers of the animal, the wrists and the ankles of the animal, the carpals, tarsals, those make up a really, I mean, probably, 70% of the bones. So it's not as intimidating as it seems when it comes to labeling and naming the bones. And again, as we go, you'll notice some of the muscular names and some of the nerve names, some of the blood vessel names. They go with the bone names, which go with regional names and regional terminology that you've been learning as well if you're taking med term. So anyway, musculature wise, there's a lot of A&P, primarily anatomy in here, a lot of microanatomy or cellular anatomy. And then there's a little bit of physiology as well. And I think really one of the key items and to understand about the muscular system is that this is part of the what they call the motor response pathway that's linked to the nervous system. So all of the musculature is responding, it's contracting, it's relaxing, and it's doing all of this because it's being signaled. So the nervous system, which we're going to get into next week, does all of the signaling. So we did skin a little bit last week. That's where a lot of the receiving tracts are, or what we call the sensory tracts. So the sensory tracts are receiving input from stimuli, whether it's external or internal. Those messages get delivered to the brain. And then the brain uh, kind of figures out or decides or whatever. A lot of times it's all involuntary. The brain is responding or sending out response signals via these motor or efferent pathways that oftentimes end up at a skeletal, cardiac, or smooth muscle. We also see these tracts ending, these motor tracts ending at glands. So if we need a certain hormone released, then in response to a certain stimulus, then we're going to see the nervous system uh, telling a certain gland that it needs to release a certain chemical or hormone. So next week we get into the nervous system more and then get into the endocrine system along with that. Actually, we spend a couple weeks in a row doing the neuroendocrine connection. So, but this week we do introduce you to the muscular system, and part of that system does involve electricity and the nervous system. So we call it the neuromuscular connection or the neuromuscular junction. So anyway, be aware of that. There is a little bit of potential chemistry involved. Again, I think it's really important at this point to know the basics of the structural aspects. When we talk about, which would be the anatomy, when we talk about the functional aspects, we're talking about the physiology. So that will come to you in more detail when you're taking your pharmacology courses, as well as some of your other introductory vet science courses. So basically, pharmacology is working with the chemistry of the body. So a lot of these physiological processes that we go through are uh, going to be what the pharmacological aspects are trying to either promote or demote, if you will, or enhance or bring down. So anyway. So that's that for those. I want to go through as so I'm going to segue. So again, please watch the two videos that go with skeletal and muscular. I think they're about 20, 30 minutes a piece, so they're very clear, concise, straightforward. And then again, you can look through those as well. You can take the quizzes at the same time because you can take the quizzes as unlimited attempts. So some students I know, they'll actually start the quiz and they'll kind of be looking through their notes and blending everything together that way. So it's really up to you how you do things. So lastly, today, I want to go through the lab simulation, which is skeletal muscle e-stim. Um, we used to do this not at Gateway, but in undergrad, would do this in wet lab. We actually would anesthetize a frog, and then we'd remove its gastrocnemius, which is its calf muscle, and then we'd hook it up to a transducer and zap it with electrodes and crank up the voltage bit by bit to see what kind of response we'd get. So yeah, I think you don't have to do that anymore, which is kind of nice. I can show you in a wet lab setting virtually how that would be done. So electrical impulses again are what are going to trigger a muscle response. One of the biggest chemicals that we think of, certainly when we think of physiology and body chemistry, is certainly ATP. ATP is the energy molecule. So going all the way back to the first week or so of this semester, when we studied a little bit of chemistry and a little bit of cells, we dug into mitochondria being the powerhouses of the cell and ATP coming from glucose and oxygen. So the main recipe for ATP is going to be glucose plus oxygen. So all of us creatures, we need to consume glucose, which is sugars, right? And then we also need to breathe oxygen in. So between glucose consumption and oxygen consumption, we can optimize the amount of ATP from mitochondria that they can generate, which is up to 36 ATP for every molecule of oxygen and glucose put together. So, cells and organs that require a lot of energy are going to generally have a lot of mitochondria. And we see this with muscles. Muscles have a ton of mitochondria because we need a lot of cellular energy. Now, one of the needs for cellular energy is because we have what are called pumps. And when we look at cellular transport mechanisms and we need to move something against its concentration gradient, in other words, we need something to go from an area of low concentration to an area of high concentration. Molecules won't move that direction naturally, so they have to be pumped against their concentration gradient. So this pumping activity requires ATP. So in muscle cells, we have a lot of pumps, therefore we need a lot of ATP, therefore we need a lot of mitochondria, therefore we need to eat a lot of glucose and breathe. So two things that none of us should have any problem doing anyway. But the pumping that is needed inside of muscle cells is going to be the pumping of calcium going against its concentration gradient and going back into the sarcoplasmic reticulum. And now, when we look at cells, we call it the endoplasmic reticulum. But in muscles, we have specialized ER, or endoplasmic reticulum. We call it sarcoplasmic reticulum. So when you're studying muscles this week, you may come across that term, and you'll definitely come across calcium. So calcium is stored in the sarcoplasmic reticulum. And when we need a muscle contraction, we release calcium from the sarcoplasmic reticulum, and then it goes deeper into the muscle fiber and causes the exposure of what we call myosin binding sites on actin molecules or actin strands. So, actin and myosin are the primary filaments that you'll come across when you're studying muscles. And that those actin and myosin filaments are what bind together and create a muscle contraction. So calcium is what exposes the binding site to elicit a contraction. And then once we need to relax the muscle, the calcium actually goes back to the sarcoplasmic reticulum and where there's tons of calcium already stored, and so that's where the pumps come in. So when we need a muscle to relax, we actually activate a lot of ATP. So it seems kind of counterintuitive that ATP is involved for muscle to contract. It's actually the ATP is more utilized when we need a muscle to relax because we get the calcium pumps pumping, and we need the ATP to get the pumps to pump the calcium against its concentration gradient, which is going back into its home, which is the sarcoplasmic reticulum. You'll come across all of that when you're studying muscles. Now, to elicit all of that to happen, or to get that to happen, we need electricity. So the nerves, or the neuromuscular connection has to be there. And so when we look at nerves, we see the delivery of a signal is occurring down what we call the axon. So when we looked at a neuron, we saw the axon is carrying the signal away from the body of the neuron. And so the axon is actually going to plug in, or a group of axons of a nerve will plug into muscle tissue. And so that's where we get that neuromuscular connection. And within the end of the axon of the nerve, we're going to find a chemical called acetylcholine, or ACH. So, acetylcholine is another chemical that you're going to come across in your studies of muscle, but we'll also see acetylcholine next week a little bit when we study the nervous system and the endocrine system. But acetylcholine is going to be released from the end of the axon, and it's going to travel across that synapse, that neuromuscular junction, and what we call the synaptic cleft. And that acetylcholine is going to dump into and attach to what we call the receptor sites on the muscle fiber. So the muscle fiber has acetylcholine receptor sites, and as soon as the acetylcholine leaves the bell, or the end, or the knob of the axon, we're going to get kind of that domino effect started. So the first domino to fall chemically is really that acetylcholine domino. And once that acetylcholine, again, it leaves the neuron and goes to the muscle fiber, that's going to then trigger sodium to move, and it's going to trigger then calcium to leave the sarcoplasmic reticulum, and then again cause the binding sites to be exposed. So the acetylcholine's the first domino. Uh, the sodium and is going to then get triggered inside the muscle fiber, which is then going to trigger the calcium to get dumped into the filament level, which is the smallest layer of the muscle. So when we rewind and go back all the way out, we're going to see in this lab activity is that in order to get a muscle to contract, we have to reach what's called a threshold. So, and we measure electricity in voltage, or millivolts. So we're going to see that there's a certain amount of voltage that is going to be required to get a muscle to respond. So that's called a threshold. And once we've reached a threshold of electricity or a voltage, that muscle is going to start to respond. It's going to start to contract. Now, at that threshold level of voltage, we're going to get a small contraction, just a very subtle, a very light contraction. So we can increase the intensity of the voltage and get a little more intense muscle contraction, and then increase it some more, get a more intense, and so on. So we can incrementally increase voltage or increase the intensity of the nerve stimulus and get a stronger muscle contraction or a stronger response. But there's what we call kind of this maximal voltage. There's a peak that we reach called the maximal voltage, where no matter how much voltage we give to the muscle, you're not going to get a stronger contraction. So that's what we're going to look at today. We're going to look at the threshold. So if I give it a little bit of voltage, am I going to get a response? Maybe not. So I have to give it a little bit more. Am I going to get a response? I don't know. Well, then we're finally going to get to a point where what's called a threshold where we're going to get a response. And then we're going to keep increasing the intensity of the voltage until we kind of peak out and level out to where no matter how much electricity we give the muscle, we're still going to get the same strength of contraction. So that's really what we're going to look at today. There's a short video here. If you are doing this on your own later, or if this video that I'm doing now isn't helpful or whatever, this short video will tell you how to set things up. But I'm going to do that with you and discuss what each of the items is that we're going to be using. So what we have here is a clamp stand. And then, so what we want to do is grab this clamp. And again, the thing you've noticed about McGraw-Hill Labs is that if you're unsure of what to grab, well, usually, like I say, they'll have a video. So you always want to read through these introductions if you're doing these on your own and watch the videos as well. They're very helpful. But anyway, at some point, if I keep moving my cursor around, I'm going to come across, it's going to give me the hand. So then now I've got 1, 2, 3 places to put this. So again, if you're doing this on your own or if you already did it, you would have had to watch that video on how to set it up. Or if I try to put it there, nothing happens. If I try to put it there, nothing happens. If I put it there, sure enough, then it clicks in. So we can just do trial and error too. But anyway, number 1 is done. Then it says attach the frog leg to the clamp. So where's the frog leg? Oh man, I don't know. Well, I didn't watch the video. Oh, there it is. Okay, so you grab the frog leg and click it onto the clamp. And then it says attach an electrode, which is the electrode. That's going to be the red one. And if you watch the video, it's going to tell you what that is. But the electrode is actually what it has the word electro in it. So we're going to use that to electrically stimulate the muscle. So again, the electrode is, you notice it's plugged into the, or not, it's locked into the clamp. And then there's a little tip on the end that's a couple, it's a double metal tips, copper, that are going to be plugged right into the muscle tissue. All right. And then the transducer, that's going to be this black one here. We're going to put that there. The transducer is there to measure the force of the muscle contraction. So what we're going to do is next up, we have to connect the leg, the muscle, to this transducer. So then we need to grab the wire and we attach it right to the muscle. And you can barely see it, but now we have wire that's connected and attached. It's tied tight. It basically acts as a tendon. So we have muscle attaching to bone. So this transducer is kind of like a bone, and then it's connected to that bone via a tendon. So we basically just tied a tendon to the end of the calf muscle of the frog. And then down here, the tendon is attached to the bone. So when the muscle contracts, it's going to put tension on the bone and cause movement at the joint. So for this activity, what we're doing is actually, then we got to plug these in. Okay, so anyway, we're plugging the electrode in. So this transducer so when this, we're going to zap the muscle, it's going to contract, it's going to pull on the tendon, which we have as a wire. And that tendon is going to pull on the bone, which we have as a transducer. And that transducer is going to measure, and I got to plug it in, it's going to measure the amount of force that's generated by the muscle. So the idea is, I think we're done with that. Yeah. So again, just a quick recap. We have the muscle of the frog, calf muscle. We're going to plug in some electricity to that muscle, and we can control how much voltage is going into that muscle with this little transducer box. Okay, and then what we have is the muscle attached to this transducer mechanism that's going to basically act as a bone. And so we're going to be putting pressure or tension on the bone, but we're going to be able to measure how much tension is being generated. And we measure that in grams. So that's how much force that is generated. How many grams of force? All right, so let's do it. We're going to set the stimulus voltage to 0, which it is already. We're going to click pulse on the data. So this is a data acquisition unit. There's the pulse buttons, this red one. And we're going to determine if any force is generated. We're going to record that data. So let's do it. Now this should be obvious, but are we going to get any force generated with 0 voltage? Probably not. So, but let's push the button anyway. Click, and nothing happened. So then we go to lab data and we go to output voltage is 0, generated force was 0. So we can minimize that. And then they want us to bump this up to 0.2 volts. So we're going to do this all the way up to 2.0 volts. So now we have 2/10 of a volt. Hit the pulse button and we didn't get anything happening. So we go to lab data, 0.2 volts generated 0 force. Okay, so then we bump this up to 0.4, click the buzzer, bzz, nothing happens. So we click our lab data and type 0.4, and we didn't get any force generated. Okie doke. Man, well, I guess we got to bump it up to 0.6 and we're going to zap it. Zip. Notice too that we got some movement there. I'll do it again. I hope it's not going to let us do it again. But yeah, notice we finally got a little bit of movement. And notice too, it recorded that movement. So this is when we gave it the stimulus. We have what's called like a latent period where we get the flow. Because remember, basically, this is acting as the nerve. And so this is acetylcholine is getting released into the muscle. And so we have to, that first domino falls. That's what's happening here. The first domino falls. By the time we get to the last domino, that calcium getting released, that's when we get the contraction. So that's why you have this little period here, a latency period, kind of like a preload period. But we do get a response. So let's now when you do it on your end, it'll probably give you a plus here so you can zoom in on that graph. So I can't because I've done this a million times. So it's for some reason it's saying you've already done this. But anyway, 50, it looks like is what our number is for 0.6. So we have our first force generated. So what is 0.6 volts would be considered our threshold. All right. So let's go to 0.8. Are we going to get some sort of contraction? We've already got 1.6, so why wouldn't we with 0.8? And sure enough, we increase the voltage. Notice we got an increase of contraction as well. Let's see. So that's 190. I'm just gonna put 80. It might be a little more, it might be a little less, but like I say, I can't zoom in on that. So just go with 80. All right, then we're gonna bump that up one and we're gonna zap it. Zoop. And again, notice we do get a contraction. And notice too, it's a stronger contraction. So we're at 100, 110. We'll say 120 at 1.0. Right, 1.0. 120. So notice we're steadily getting stronger contraction or strength of contraction. We're generating more force as we increase the voltage. So we went up 50 to 80, so we went up 30 grams of force. When we went up 2/10 of a volt, we went up another 2/10 of a volt. We actually generated 40 more grams of force. So 30 more between here and here, 40 more between here and here. Now, when we bump it up to 1.2, do you think we're going to go, is it going to go up to 170? I don't know. Does it go up incrementally like that? Well, let's find out. You see what I mean? So 50 to 80 is 30 difference. 80 to 120 is a 40 difference. So then are we going to get a 50 difference here? So are we going to get 170? I don't know. We're going to find out. 1.2 volts. Definitely going to get a contraction. How strong is it going to be? All right. So it looks like it went up to 150. Boy, I don't think it's 170, but it's definitely 150. It's probably like 162 or something. We'll just put 160. 1.2. So we did get we're staying even now at this point. So let's keep going. Because remember, we're basically trying to see, is there a maximum voltage that we attain with this muscle. Notice too, this is the same where we start to get the contraction. So the latency period from again when we dump acetylcholine to when we get calcium exposing the binding sites, that distance is generally the same. Okay, we did go up. Looks like we went up 200. We'll just say 210 on that one. So 1.4, oopsie, 1.4 gave us 210. So there we go. That went up 50. So, all right. So we're going to keep her moving. 1.6. Oh, all right. We went up higher even, it looks like. So 210, 20, 30. Let's say 235. 1.6. Oopsie. 235. That looks good. So we didn't quite, it looks like we might be tapering off a little bit because the distance between the numbers as we go up it just shrunk, right? So we had a 30 distance, 40 distance, 40 distance, 50 distance, now only a 25 distance. So we might be getting close to, not to give anything away, hopefully the you know, spoiler alert. But anyway, 1.8. So let's bump it up. 1.8. Beep, boop, beep, boop. Here we go. Looks like 200, 210, 222. Looks like the same, doesn't it? 235. So we might have hit our maximum threshold here at 235. Bing bonk. Okay, now let's go up to 2.0. Zap it. Beep, boop, beep, boop. And sure enough, 200, 10, 20, 30, about 35. So we've reached our maximum voltage threshold at 235. And we reached our initial threshold was at 0.6 volts. We reached our maximum, looks like at 1.6 volts. So you should observe that values of 1.6 volts or greater elicit 235 grams of force. We did see that, didn't we? So we would call that our maximal stimulus. Yeah, muscle will increase its response from the threshold stimulus up to maximal stimulus. Any stimulus above maximal will elicit the same maximal response. So I could crank it to 25 volts, and we're going to get that's the maximum threshold. All right, I think that does that. Now, this next step to complete the lab, you select you graph out, you have options here. So we're going to just do one graph. So we're going to do voltage on the x-axis and force generated on the y-axis. And we're going to do a line graph. So let's create that, see what it looks like. So there we go. Again, we put voltage on the x, force generated on the Y. So we gave it 0 volts and we got 0 force. We gave it 0.2 volts, we got 0 force. We gave it 0.4 and got 0. So now we bumped it to 0.6 and we finally got some sort of response. So we could say that 0.6 is that threshold voltage. Now, what if we gave it 0.5? Would we have gotten a response? I don't know, because our machine doesn't do 0.5. So we just go with what the machine lets us do. And then notice we increase voltage and we steadily got a stronger output or stronger force generated until we got to 1.6. And then we saw everything taper off. So again, this is your maximal force generated. And once you've done that, you hit save and then you go to phase 4. What effect does increasing the voltage have on the force generated? The higher the voltage, the stronger the contraction, up to a maximum force. That pretty much sounds like the definition, doesn't it? Let's read the other ones, though. Higher the voltage, stronger the contraction without any maximum. If that was the case, our bar graph or our line graph would have just kept going, but it didn't, right? It plateaued or leveled off. All voltages cause the muscle contract at the same force. So again, if we did that, we'd see a straight line across on our graph. So we know that it's got to be A. And there we go. And then it has our data and it has our graphs. And again, you don't have to print these off or save them or submit them, but if you wanted to, you could. And you could even save them as a PDF file. You don't need to do that, but you could. And that's that. And then that should give you your points, and you should get your 25 points or however it works on your end. I'm not sure. Questions about the lab? Now, when we get into pharmacology, or you get into pharmacology, you're going to see that when an animal has muscle, maybe get we need to anesthetize an area. So if we give them some sort of acetylcholine blocker, so acetylcholine can never get dumped into the muscle, then the muscle can't contract. So we could give them some sort of acetylcholine blocker. And by the way, when you get to pharmacology, you'll notice that there'll be drug categories that are either adrenergic, so they stimulate, mimic kind of like an adrenaline response, or we'll see cholinergic, which is going to involve more rest and digest, more of that parasympathetic. So that's kind of your teaser trailer for next week. I'm going to leave you guys there for the weekend. So please keep plugging away on your units, and I will see you guys next week. If you have any questions, of course, please send me an email and I will get back to you in quick form.